Good afternoon. Welcome to the fourth day of Go to Space Hackathon. The previous 3 days, we have enjoyed interesting presentation and discovering some success stories about the use of Earth observation data. Also, we have learned about several DIAS platforms, Creo DIAS, Onda DIAS, Mundi Web Services, and Wikeo. Today, the session is dedicated to the fifth platform, Sobloo. The first part lasts 1 hour and will be dedicated to explaining a use case for the Starling portal, specifically how to monitor for Nestlé their oil palm sourcing at world scale. Ludovic, Augé, product manager at AIRBUS, and Diego Pozo, EO data expert at AIRBUS, will give you some guidelines on how to proceed for a similar use case on Sobloo. The second part will be dedicated to the training session on Sobloo Platform. This is one of the platforms which the hackathon teams can use for their project proposals. I remind you, Creo DIAS and Sobloo will be used during the team work days tomorrow and Saturday, and I remind you already have access to both. Very good. We already started with the first block with Ludovic Augé and Diego Pozo. You're welcome. All yours. Diego, Ludovic, welcome.
Okay. Hello, everyone. Nice to have you all on board, and happy to support the hackathon. So, my name is Ludovic Augé. I'm the project manager for Sobloo, and I'm going to give you an overview of what is Sobloo. Just to do that, I would like to do a side step not to talk specifically on the DIAS. You might have heard of it already, but I wanted to highlight a typical example of what DIAS can help you do and what it could look like with Sobloo. So there will be 2 parts in our presentation. Firstly, just a presentation about the Starling use case and the connection that can be made to DIAS. And then secondly, Diego Pozo, our operation manager, will do the presentation of Sobloo and give you more detail on how to use Sobloo. During my presentation of Starling, I will start with just an introduction and overview of what is Starling. And then Adrien Siegfried, our colleague, will help us will demonstrate you what is a Starling portal to give you a real an actual view of what it is, what are the products you can get out of it, the results. He will explain the way the front-end layer has been developed, while I will be presenting share our experience on the back-end. So let's start. So the Starling use case. Why talking about Starling here with Sobloo? Firstly, Sobloo is a DIAS, and DIAS are considered great enablers. Have been designed. This concept is here to help unleashing the potential of all the Copernicus data and to be able to use those data with a convenient environment, with cloud offers, support, and services to turn this huge amount of valuable data into high-value information. One of the use cases could be the helping in decision-making, and this is where it sounded interesting to us to present you Starling, because Starling is a service that has been designed by Airbus Defence and Space. It started something like 5 years ago, if I remember well, to support one of our customers, Nestlé. And I'm going to present Starling because Starling is a typical use case of how can we combine the use of cloud technology, huge amount of data, artificial intelligence, etc., and do and also be able to go with the challenge of switching from R&D to full ops at industrial level worldwide. So let's discover it and see what it is more in detail. So Starling is a kind of recipe where you will find a huge amount of data, many data coming from Copernicus program, Sentinel data, but also you will find inside Landsat data and also use of spot data from AIRBUS. This service has been set up in the cloud because right from the start we had to deal with the challenge of dealing with big volume of data, but you will see that we had just at the moment a decision made by our customer to go just much bigger. We have to work at large scale, and along our process, you will see how did we switch from a regional scale where we could deal at some levels with some manual operation that could no longer be the case when switching to a worldwide scale with a very huge amount of data. And all this was in the frame of a project. So in the end, we had to deliver in time, on cost, and quality to our customer. So Starling, what is it exactly? Starling is a service we have designed for Nestlé to help them monitor their oil palm sourcing worldwide, because to them that's the main concern, as everyone knows that oil palm is considered as one of the key drivers of the deforestation. So their problem was about the image and the impact that it could bring on their revenues. So to help them work on that and to demonstrate that their sourcing is correct, and to help them also act on their sourcing chain, because they had to be able to check if in their sourcing there were things that were done badly and that to act on this. They asked us to help them. So we built this service that basically consists in monitoring some areas. As soon as the data is available in this area, we use it. We do classification, compare it to reference, detect if there is a change in the classification between forest and oil palm areas, trigger alerts, and make all this information available to our customer so that he can take appropriate decision and communicate on that. So this service is based on basically the delivery of BASEMAP, a land cover map, giving classification between forest and palm oil community of a very huge area, which is 6 million square kilometers over 3 continents, 22 countries. This means that it's a surface bigger than European Union that has been to be analyzed and covered for 20 years of historical archive. To do that, for sure, we cannot mash and digest all those information, all those tons of pixels into very high value information without having the help of artificial intelligence. So we had to define a way to create automatically those base maps, and then be able to do this in the first step manually. But when the ramp up came, we had to define a way to do it automatically. This is where artificial intelligence helps us and machine learning. The purpose of all this analysis is to deliver quarterly monitoring reports for the deforestation over all the region where our customer was sourcing his oil palm. So the idea was to have this data-driven approach. As soon as an imagery arrives, it triggers processing, comparison, and so that we could put all of this information in a big big database, so that we can feed then a frontal layer, a front end that will be demonstrated by Adrien. And this frontal is the entry point for the customer. So we had to do that and to tailor this front end to the customer needs, so that the information is not only available, but it fits what is needed by the customer, and it's really usable to take decision and act with it. So there has been a lot of work on the front end side as well, not only on the back end side with this huge amount of volume, but there's a lot of work in making the things in the appropriate way so that it is smart enough to be useful. And we also do some weekly computation of analytics that are helpful to make those decisions about what should be done on the field to act on the deforestation. So basically, Starling, we can consider that we have 3 background steps and then one step on the front-end side. On the background, firstly, we make use of imagery from Copernicus, from Landsat, from AIRBUS constellation. With this imagery, we feed 2 processes. One is the BASEMAP, the automatic creation of a reference layer. The second one is the monitoring. From this reference layer, every new data entering the areas of interest are automatically used to generate comparison so that we can trigger alerts. For sure, all this is based on automatic process. So we had to define a way to provide quality control, but for sure not over the entire the exhaustivity of the data. That was just impossible. But we had to define a way to sample data and make sure that we can assess the quality and that the classification is good, that the events detected like deforestation to forest to oil palm was correct, etc. From this huge amount of data, we just generate a very concentrated amount of data that is delivered into an internal database, which is the backend basically of the front part, where you will find the GUI presenting the results, having interactive way of presenting the data so that the people on the customer side can inquire, analyze, and check and anticipate the problems, so they can fulfill their commitment of being able to engage their suppliers, coming back to them and work with them to limit deforestation, to also propagate a feedback on the ways they do their sourcing to transform their industry, and also to be able to communicate, to demonstrate what are the impacts and what are the progress done. So basically, that's the concept of Starling. So now I'm going to leave the floor to Adrien, who acted as the guide to define this front-end part, and his work has been mainly to do the work to go from the customer requirement to the development teams and iterate on that using agile methodology, because one main challenge actually was in the fact that the customer didn't knew actually what he wanted. So we were doing some co-working, some co-creation with the customer at the same time, and Adrien handled all this process. So he's the good guy to present you now the front end. So
hi everyone. Very pleased to be here and to be able to demonstrate Starling capabilities. So let's. So yeah, as Ludovic said, I worked on Starling as the product owner. I made sure that the Starling web platform was easy to use and adapted to users. And this is not a simple task. But I'll come a bit on some tips about this later on. So if I can show my screen.
I have stopped presenting. So
is it working? You can see my screen?
Okay.
Yes?
Yes, it works. Yes.
Okay.
Yes.
Okay, great. So first of all, Starling is a satellite imagery, meaning that you will have different ways of viewing the data, and the first thing that comes is the image that comes from the satellite. So here we have a first view of the satellite imagery. right. So this is the demo effect I was scared of. Okay, so let's just a second. I suggest I'll talk a bit about the process behind Starling, and later on let Ludovic go further with the following, and hopefully we'll be able to have a little demonstration at the end. Sorry about that. So if I can share again my screen. So yeah, about the demo. So I wanted to talk about a bit the context behind various projects. So we have with Starling a very special case where we had a lot of different kind of data. We have the satellite imagery that comes from various forms. We had high precision and high volume to handle. We also have another kind of layer which we call the BASEMAP. So this is the land use of the Starling layer, meaning that we are capable of knowing on the ground what is going on. Is it forest? Is it maybe another commodity that is being grown, like palm oil or pulp and paper, and so on. And then we have a deforestation layer. The deforestation layer is the difference that we can see between, at some point, forest, and then another time we don't see the forest, and we can basically say that there has been deforestation. And on top of that, we need to include the supply chain data. The supply chain data is all the data that has been embarked with our customers. So, for instance, Nestlé, and for instance, the palm oil industry. We have various actors. We have mills that process the palm fruit and then make it an oil. And these fruits come from the concessions, so the boundaries. So the full supply chain is actually various kind of information that comes from the boundaries and the mills in order to obtain the palm oil. And we have different use cases. So for the same web application, we wanted to have a tool that would be useful for GIS experts. So meaning that they would be able to take the data, run some interactive analysis tools, and get some feedback on it. But we also want, well, the main, yes?
Do you have some slides that you want to share while the demo is run? Maybe some from Starling on the background.
Yes. Ah, okay. So you weren't seeing my
No, sorry. Yeah, I thought that was
so
the
now
case.
Now it's sharing, right?
Yeah, now that's
good.
Can
you see my screen now?
We can see it now.
Oh, sorry about that. Yeah, it must have been a bit awkward. So yeah, as I was saying, the various data, satellite imagery, the BASEMAP and the deforestation layer, and then the supply chain. So this is the first set of various data that it's a context that we have to handle, coming from various size and with various challenges. One of them is by the volumetry. Another one is by, well, how do you handle it? How do you serve it? And how do you make sure it's accurate? And the third one, the supply chain, is, well, it comes with the challenge of how do you get this kind of information from a client? And then we want a tool that is adapted to different use cases. So meaning that we have GIS experts that want to interact with this, with the information and be able to extract the info and leverage it for something else. But we also have the responsible sourcing managers, our main target in the end, because they really need a very simple tool in which they have a green, yellow, red system in which they know where they can focus their efforts and work on how to fight deforestation. And then we also have experts on deforestation, such as our partner, the NGO Earthworm, that does a huge amount of work in trying to understand what is considered deforestation, what is not, and what should we be doing in certain cases and not with others. And so various data, different use cases, and also time constraints. With time, because we had a product to deliver, budget, we couldn't we have to be very careful in our spending, and resources, because we had a set amount of people that could be working on this project, and it couldn't be expanded. And the question is, how do you manage in this context to get a product and to have customers that are using and making, well, are happy with the product? And for that, you need a process, and a very, well, we decided to go for a human-centered approach or design, meaning that we try to really always go back to users' needs. Because in the end, if they're not happy, or if we don't understand their needs correctly, well, the product will not work. So yes, so this is the basic principle. There are many approach or process or framework where you can implement a human-centered design. The one I'm showing here is, I think, taken from design thinking, but it's always kind of the same idea. So first, you really need to understand your users. So for that, you have to, well, make user interviews, really talk to them, try to understand their motivation in using the software, their limitation, their frustration, and how they can be happy with it. You also need to do contextual inquiry, meaning that you really need to make sure that you understand how they would use the system, but directly from the computer. You're behind them and you ask, okay, so what was your last test? What you were trying to do? And trying to understand really on a concrete scenario, what are they trying to do? This helps to build like a projection of the ideal users or average users that would use the system, and always refer to this image in order to find solution that is the most fit. Then you need to define, because this is a lot about understanding and going in many different directions, but at some point you have to frame the challenges and to set, okay, this is what we're going to do with Starling and nothing else, just this about this. And for that you need the stakeholders and the people that are involved in, well, sharing the vision of what it is. Then you need to ideate, meaning that once you have the frame of the challenge and you know what will make the users happy, you need to find different ways and solutions in order to help this. For this, you have some workshop that is how might we, so thinking about how could you improve this, how could you improve that. So it's just a small question answers with users. But mainly the main thing here is participatory design, meaning that you need to take the users with you in the design process and making sure that well, their ideas are getting inside the conception, the design space. This is very important. After that, you have your the solutions you want to build, and now you need to prototype them. And there's various ways of prototyping, because the prototyping is not the end product, it's just in between. And you have a very, let's say, low fidelity with interactive wireframes, meaning that you can click on certain areas and it will go through a kind of a scenario. And you can have high fidelity mockups, and both are prototypes that fits different use cases. But what we want to do with them is to actually test them in the end. So maybe at early stage, it's interesting to have interactive wireframes, meaning that you can visualize how the application might go between the various clicks, and then maybe going a bit further in the detail and having a very pixel perfect application. Finally, you need testing, because this is in the end what is the product is supposed to be. Is it like useful or not? And in order to do this, well, there's one method called design walkthrough. It's really simple. It's just putting the users in front of the web application and asking them to do the task you already analyzed in the empathize phase. Meaning, so you're asking them to run the task, and you just observe how is the web application responding to the user interaction. And this gives you a very interesting feedback loop, because then you will know if the design you've thought, the prototype you've built, is fit or not for the users. And there's a retroaction loop. So once you have finalized, once you've done with the testing, you can go a bit back in time and thinking about, okay, maybe we should try to solve another issue, because this is not just about that, it's maybe also about. So you go on the second iteration and you try to ideate a little bit more precisely on something else. Then you prototype the specific solution, and then you go back again with testing, and then you're sure that you're building the right product. So this might be a bit tedious, but in the end, it's really knowing where you're going and taking all the steps in order to go. So let's go a bit concretely with the Starling use case. So we really started from nothing, and we had just a vague idea that there was a lot of data, a lot of use cases, and people wanted to use the platform. So what we decided to start with is a very classic workshop called Google Design Sprint. I'll let you Google it outside. It's just very simply a way of setting everyone together and discussing in a very directed way how you want to build a product. In the end of this design sprint, we managed to embark some users, and we have thought about two ways of presenting stuff, meaning that maybe there's one way where we just really focus on one area, so it would be the first one, and we have like key metrics that was a bit an overview, an overlook of the area. And another one that would be more map-centric, let's say. So we have still the map, and we have various ways of providing the information. And yeah, and we thought that these two solutions were maybe both interesting, but we wouldn't know which one would be better. But that's fine, because this is part of the process. You have a really cheap prototype, and now you just want to test it and knowing where you can go. So we went for testing. We did this with Ferrero, actually. And well, the feedback was like the first one was much appreciated because it was simpler, and it sounded like they fit really much their needs. So we thought, okay, let's go for that. So this is where you see the first release, which is the actual development of Starling. This is maybe the first version that has been released. And so we see that there was one area, and we have some key metrics, and we see the evolution, and yeah, we were happy with the results. But because we thought they were coming from an initial decision, we knew that we had to test, we had some answers, we tried to develop, and then we had the first version. We went to Nestlé headquarters, and actually what they said is that it was not at all fitting their needs, because we completely missed the point of having a very scalable and much more interactive application. So it was a fail, and we had to go back a bit and rethink a bit our solution. And this is where we decided to go a bit more map-centric, as you can see in the final version, but still with some key metrics on the top. So this was the things that were appreciated, to have some analytics on the area and so on. And this is then the current state of Starling, meaning that we currently make some testing in order to make sure that we are fitting the user's needs. But yeah, it comes from very far away, where we really have no idea what we can do with this data. Had a first initial approach, thinking it was okay, trying it out, making user test it, understand that it was completely missing the point, and reconfigure it a bit, the application, and went for another version. And here it is, and yeah, and people are using it, and they can leverage really the data the way they want it in order to have to be able to fight deforestation in, for instance, the palm oil industry. So yeah, so this was a bit on the approach I would suggest when you would be involved in building an application with different contexts, maybe a lot of data, many of use cases. Well, try to figure out an approach where you have the user centered and where you can involve it in the design space, and also, most importantly, in the testing, because this is where you know if the product fails or not. And then I'll just add a small personal feedback on how design can be a speed up for this process, because in the end, we always think about design as maybe something cosmetic or aesthetic, and this doesn't really change the nature of the product, or cannot maybe make it successful or not. But I mostly disagree. I think design should be in the heart of the development space, because, well, it can be really a speed up factor. And for instance, one of the key things that I've observed from the development of Starling is that when you try to find the right patterns, so this would be the interactive patterns, for instance, or the design patterns, then you can try to build somehow a first system that is first very friendly, user-friendly, in the sense that if you always see the same look everywhere in the application, well, users will feel at home. So this is already a good point for user experience. But most importantly, it's for the development phase, where you have always the same kind of blocks that are repeated everywhere. Then it works, because developers don't have to redo it all the time. And so you win on this. And so, yeah, and really finding those patterns and refining with testing and end users is, I think, is a key to have a speed up for the development of an application. And here's some example of the Starling, taken from the Starling web portal, where, for instance, you have the side panel and you have different ways of displaying the information, where we try to always reuse the same pattern. The same way for the map, we try to have to separate into two categories. Either it's more modal, meaning that you're in a specific mode and you can do certain things, or it's really about tooling and you have another way of representing it, but always trying to follow the interaction between these two. And another one is about filtering. And for instance, when you search about something, we'll try to figure out one good way of doing it and always replicating it elsewhere. So these are very quick examples. So yeah, this is about the process behind Starling and mostly the UX part. I'm going to give then the flow to Ludovic, that will speak a bit more about the backend and how the data is being processed. Ludovic?
Okay. Just, are you going to do the portal presentation right now or at the end?
At the end. I'll give you a small hand
Okay.
when I'm ready. Okay.
Okay. As soon as everyone is asleep, you present something more funny. Okay.
Yes, I do that. Thanks.
Okay. So let me switch to my presentation. Okay, so back on the slide. Does everyone see it? Is it okay?
Yes, it's okay.
Okay.
Thank you.
Okay, good. So, as I mentioned, the Starling project started with some R&D study more than 5 years ago now, just before 2017, as written here on the slide. And it started in the approach of how to check how can we monitor something on a regularly basis. And then we had this co-experimentation starting with NGOs and also with Nestlé. So the first target, the first business model, in fact, was let's try to make Starling at a landscape level, meaning a regional level, where basically we would produce a coverage map, a reference map, and monitor some deforestation of over very specific areas made available in selected countries where that was the most relevant, targeting the whole palm industry. So we chose Indonesia and Malaysia. And we were offering different regions where to do this monitoring. Basically 7 landscapes you can see on the right side, upper right side, ranging from 10 to 20,000 square kilometers. The process was semi-manual or semi-automatic, as you like. Mainly the base map, the reference map, was produced manually by experts. So at this scale, that was okay. And it was taking something like 3 months to generate a landscape, a base map, and the landscape, the monitoring of it. We already had an automatic processing chain on GCP, on Google Cloud Platform, sorry, because at that time the DIAS concept was not yet implemented. So we decided to go to Google. That was the most simple to us at that moment. And we already had this data-driven triggering mode. As soon as the data intersects in the storage we were monitoring, as soon as the data was arriving and intersecting one of the 7 landscapes, it was triggering its classification, then its comparison to the base map. That was feeding the system with semi-refined information to be able to present it to the end users. And on the web portal, we firstly decided to go with standard tools, basically at this moment S3 tool. And for sure, the supply chain we didn't go to the extension of presenting the data consistently with the supply chain of the customer. For instance, with the location of the oil mills, etc. With no analytics. That was the first step. So that was our first approach, and we have iterated on with Nestlé on that, and finally, by the middle of 2018, 2019, they decided that okay, that was interesting. That could be that could fit their need, their purpose, but they didn't want a cost model on based on square kilometers they were monitoring, because they wanted to do everything right from the start, the full picture right from the start. So we had to find another business model, and the result was mainly a few things that were really, really important with high impact. Firstly, moving from 10, 20,000 square kilometers to 6 million square kilometers, there was a huge ramp up to do, a huge scalability challenge to deal with. Secondly, this is not just a matter of having huge amount of data. It's about infrastructure and architecture, and see where could be the bottlenecks. And thirdly, adapt the way we present the information and go further in the value chain to meet the expectation of the customer. So we had to do this in something like 6 months. So basically, we had 3 big challenges, because adjusting the size, the scale of the service was a challenge, because it was bigger. But okay, everyone was saying at that moment, okay, you have the cloud, that's scalable, so it will be easy. But it's not just a matter of computing power. It was just about having an idea of what does it represent to handle such a big volume of data, and secondly, how to adapt our processing chain to cover this, and to fit, to have our cost fitting the selling price. As the structure of the selling price did change, the business model changed, we had to review our architecture, because the way we had implemented the service on the first step were generating costs that were not in line with what we were able to sell. So we had a strong reverse engineering process to redefine, to rewrite our chain and our code. And third part, the part where Adrien spent a lot of time, is working on the frontal. For sure, this part is not consistent, not directly in line with the DIAS concept and Sobloo. Fair enough. But what we clearly saw there is that it's one thing to go to the cloud, to use cloud technology to be able to have technical power. But if you want to make it efficient and not to get lost in the middle of this complexity, you really have to make sure of what do you have to do. And in that context, as Adrien explained, that was an iterating process with the customer, because he was clearly discovering the quality of the information he could receive, how interesting it was, what were the limits of this information, but also what were the opportunities from this information, and all those things were added in an iterative process. And if we hadn't firstly worked on the frontal part, really defining what the customer wanted, we would have spent so much time in doing again the rewriting of the code, that would have been endless, and that would have been a failure. So basically, the impacts were on first point, how to go to multiply the number of pixels we have to handle by something like more than 1,000. how does it fit into our two chains, the BASEMAP generation process and the monitoring process? How to make it automatical, because at the moment BASEMAP made manually were no longer an issue. Thirdly, about the control, the quality control, we couldn't afford to have an exhaustive control strategy. So how to define a sampling strategy to make sure that we have quality without being overloaded. And finally, how to adapt the front end.
Yeah,
So
Ludovic,
maybe coming back to the, yes?
Yeah,
Please?
if you, I'm ready whenever you are. And
so if you like, maybe it would be good that you present something now so that the people will have something in mind, a picture, and then I will come back to the end of my presentation if you like.
Sure. So you should be able to see my screen now?
Yes, yes.
Yes, okay, great.
Okay.
So this is the Starling web portal, and we have a focus on the Southeast Asia, as there's mainly a lot of palm oil. So we have truncate all the provinces into small areas, which will be more easily, efficiently processed. So yeah, this is why we have some landscape. This is how we call them. And the first thing we're working on is to have a satellite imagery in order to, well, present the situation of the ground. And we do it by providing relatively accurate or precise satellite imagery. So these are the first layer on which we add then the artificial intelligence processing in order to have two main products. One is the BASEMAP, which is a layer that illustrates the land use, meaning what is this land is doing. So for instance, we have green, more things that are forest, and yellow, it's corresponding to palm oil, for instance. And another one is the monitoring, which is here. So and the monitoring matches the differences between the forest and the non-forest. So here, for instance, we can see that the deforestation is attacking a main forest land here, and we already can see from the satellite imagery that this is mainly palm oil. If we switch to the BASEMAP layer, we probably see this. We have this as well a production of a commodity. In order to adapt to various use cases, as I mentioned, so we try to implement some little functionalities such as like a transparency for the BASEMAP in order to make some differences. So we see it's kind of accurate on this area. This is like a good feedback we can already see, and well, some tooling in order to understand if what drives the deforestation. So for instance, for the BASEMAP here, we can use a land cover over time, so a distribution of the different classes of the BASEMAP over time. So meaning here we can see that clearly the forest is decreasing for which appears to be, well, other commodities we don't really know, and what we know is palm. So palm oil has been growing at other commodities as well. What we know is that deforestation is decreasing, that's for sure. And this kind of interactive tooling is helpful for GIS experts in order to understand what drives the deforestation. But so these are more for the GIS experts, and for, let's say, general public, we also had time series, which is a neat way of viewing the evolution of the BASEMAP over time. So if we can have this picture. So we can see the evolution of the deforestation year after year. Well, I don't know if it's very clear. And so yeah, and this allows us to have a very neat differentiation of to appreciate how well the deforestation has been decreasing in a quick, very efficient way, let's say. So these are the tooling that has been built around Starling in order to adapt to different use cases. And I've been speaking about the BASEMAP and the satellites underneath. We also have the monitoring layer, for which we also have different kind of interaction. So one of them is to, let's say, quickly understand where is the biggest patch of deforestation. For this, we use the interactive analysis that from the area given will make pop out the highest deforestation. So here we see that this is the one with the highest deforestation, and we have a direct zoom on it and see where it is. And most of the time, people are more looking to a certain period of time. Maybe, for instance, to work on the latest quarter. So they will use the period setting in order to just have this period filtered out, so that they can maybe work on, I don't know, some differentiation between the 1 year or one quarter towards another. This is just the raw images that we have parsed with that have processed with different algorithms in order to have this kind of information. But it doesn't really help the end users, because what they want to do is to understand their impact with the supply chain. So what is missing here is actually the supply chain information. So as I said, there are two main things in the palm oil industry. There are concessions, where you have the areas where you produce the palm, and you have mills in which you have the oil, so every time we have a way of having, so these are concessions where the palm is being growing, and then they are always referring back to one mill that will then process it and make the oil. And a client as Nestlé, for instance, will buy the oil to a certain mill and want to assess if this mill is at risk or not towards deforestation. And for that, well, there's a lot of things going on, and I won't be able to explain too much. But what we can see, for instance, here is that this mill is partially okay, because mainly most of its production comes from concessions that has been labeled as clean or no deforestation since 2016, that we can consider it's fine. But for some of them, there's a problem, and they need to see what the problem is. So it's trying to go from the concept which they expressed of having a very simple way of having green, yellow, red mechanism, so as we see, but still trying to go a bit further and give some detail on what might be going on. And for instance, here the mill is in red in the end, so this is the icon of the mill, and so we need to do something. We have to do something because it's not completely good. So yes, this is about the scoring of the mill, and we have added some analysis around the supply chain, the different supply chains. So for instance, for this mill, since 2016, we can see the different deforestation that has been linked to this mill for 5, 20, and 50 kilometers radiuses. So these might sound a bit abstract or random, but actually it's the work from our partner, the NGO Earthworm, that has been working, decided that 5, 20, and 50 kilometers is the radiuses that we want to work with. And meaning that we are looking for all the deforestation around the mill at these radiuses. And so what else could someone using Starling could do is then to try to figure out, maybe working on a particular patch of deforestation, let's say, I don't know, this one, and trying to measure the distance with the closest concession. So here we have, for instance, approximately 8 kilometers, and another tool is to try to find it closest to the mill, and this would be 53, for instance. And this gives some indication on how involved the mill can be with one deforestation, for instance. Okay. So this is just on the mill level, but we also have a very scale to scale it a bit further. And how do we do it and still keep it simple? Well, we just use simple patterns of green, yellow, and red. And this was kind of appreciated with responsible sources managers, because there was an easy way of grasping the seriousness of the situation or how good they are going, and meaning that they see the greens, and their main objectives, their goals, is to make this green higher. And how they do it? They do it by cutting out the mills that don't cooperate or are having issues, too many deforestation that it's impossible, or trying to work with mills in order to set up a place, monitoring system in place, and things in order to control that they are not associated with any deforestation. And so this was a very local point of view. And another big challenge that we have faced with Starling is to always try to figure out the right scale of information. Because here, for instance, you don't see any concession, you don't see the monitoring, and still Starling makes you some kind of way of knowing that, for instance, this area is much more red than this area. So you can still work and use Starling on a high zoom level. And this was actually expressed by the end users, and the only way you know it is by putting a test version in their hands and collecting feedback. So yeah, and this was a whole challenge in order when should you start displaying deforestation, when should you start displaying the concession, when should you start displaying all this various kind of information, and when start, for instance, showing a very clear satellite imagery towards the a less precise one. Okay, and just I'll finish. So there's different ways of interacting with the tool. We have seen that there's a base layer of information. On this, we have process in order to make to gather intelligence out of it, let's say. So the land use with the BASEMAP, and some deforestation with the monitoring layer. Then we add the supply chain data, so the context data of the users, and we try to make all the right tooling for them to mix these two kind of the information together. But the next step is to try to have import and exports working with them. So this is why we have built some Excel exports that they can run just for this given area or for the whole planet. And this is another way for them to work a bit offline from Starling, for instance. But they also have another kind of export that is directly from one mill, for instance, which matches actually their needs. They needed an export for one mill because, well, they're going to talk to the people involved with this mill, and they need a way of leverage. And this is given by an export where they're showing that this export PDF actually shows the area, and with all the deforestation, if you want to show them. And it's a very clean way of well, it's an efficient way of having leverage towards your supplier when they don't want to cooperate, for instance. All these of kind of information, you can gather and collect them by having the user feedback. Yes, this is the main thing I wanted to share with you today. So yeah, that's it for the demonstration.
Okay. Thank you, Adrien. So yes. I'm just going to finish my slides till 5 to 10 minutes, and that will be okay.
Okay, that's all for you now, Adrien, Diego, and Ludovic.
No, I have just 5 minutes left, and after we can do the break. Is that okay for you?
Yes, we are going a break. We're going to make a break.
I still have a few slides to present.
Now, bueno.
Okay, Ludovic, perfect. You finish the first part, okay, and then have a break.
Okay.
Okay.
Okay, good. So, just to finish and to come back to the initial concept, talking about the DIAS. In Starling, you might have understood that, okay, we're doing a lot of things with a lot of data for a very dedicated purpose. We had to present in a very adapted way to our customer. But basically, what we have here was a BASEMAP chain and a monitoring chain to be adapted, to be scalable and be cautious of where are the bottlenecks. to deal with the data, the storage also of the results, because now it's not just a matter of having a few base maps, but to have a lot of base maps, and to be able to connect it to presentation layer using GIS technologies and function as a service. And of course, so a few things like handling the identity of the users, etc. I will skip this one because it's probably not the most interesting. It's far too dedicated. But basically, what happened is that we had to conduct at the same time R&D to define machine learning algorithm to automatically build the base map, deal with bigger data, integrate the biophysical transformation of the data to be able to do the classification, to structure the results, etc., etc. And then in parallel, we also had, because of the constraint of delay, we also had to be able to scale up everything, going from a few machines to clusters of 1,000 machines, 8 cores, so allowing to have something like 8,000 processing in parallel at the same time, to be dimensioned to fit something like 10 million square capacity, just a bit higher than what was requested. So there was a huge work of refactoring. Aside from this, we had two other challenges. To industrialize it, because the purpose was not to do a POC or to do a wide-scale demo. It was the purpose was to deliver to a very demanding customer quality analytics in a continuous way. And to him, it was clear that he didn't care that the data was coming from satellite, that it was complex to do, that was a big machine we could be proud of. They didn't care about that. They just wanted the results timely. And one last thing about the production, dealing with 6 million square kilometers, just for the figures, over 20 years on 22 countries over Asia, Africa, and South America. This represented nearly 500,000 satellite images, more than 2 petabytes of data to be stored. And if you put all the computing times one after the other, it's something like 186 years of processing time. So that was a huge and massive thing to do. I'm skipping this to go further. So basically, from this experience and coming back to the DIAS, the lessons learned was that we did the choice to design from the user, from the front end side, and that was a good guess. But we had to deal with new technologies, exploring time series analysis, artificial intelligence with machine learning, in parallel of ramping up on the operation and scaling up the system. So that one key thing was to have the right skills at the right moment, so to have the dedicated team to think of who would be the experts to have now on board at that moment, about also GIS, this kind of thing. And as artificial intelligence is not just an end by itself, it's just a tool and it's not perfect. So we had to implement some supervision and quality validation process. The huge need was to be able to handle R&D and industrialization right just in the same pace. So how to make R&D and operation work together side by side and instantly. That was really the feedback, the lesson learned is that part was probably one of the most tricky, because people of R&D had their own environment, while the operation had their own environment with not even the same technical stack. So a lot of work on reworking on that. The lesson learned also is about the cloud. For sure, it's an amplifier. You can go 1,000 times faster, but when you miss something, it brings you problems maybe 10,000 times bigger. So the huge challenge was here to be able to start on small things and grow quickly and not lose this, and to be able also to redefine the way we did our architecture, because as the business model changed, the cost model underlying was not fitting, and we have to redesign a few things about that. Because when you're in the cloud, you pay as you go, fair enough. But if you just think of going to the cloud as porting your legacy application to the cloud, maybe you're making a first big mistake because you have to redefine the things. You will be exposed to probably big costs you didn't foresee. And for sure, in this context, being agile was a must-have, but it's not so easy also to be agile. It requires a lot of work, or a lot of discipline among the teams. If we had to do this, so as I said, this started before the DIAS, before Sobloo. If we had to do this with Sobloo, what would it bring? Sobloo as a DIAS would bring an easier access to data. We wouldn't have to implement the data access layer. We would already have a catalog, storage, and we could access data at full scale, meaning that you don't use 10 or 100 images locally, work on it, and once you have to go to the full scale, download other images and do this. No, with the DIAS concept, you are able to do this right from the start at the full scale. With the cloud environment and the data close to each other, we have something very efficient for machine learning at a big scale. And aside from this, within the DIAS concept, you have all these concepts of having services and tools alongside with the cloud and the data. So this would be very useful for the R&D, because you could have the people from R&D working with Jupyter notebooks, using already present algorithm and pre-processing, being able to work at scale, as I said. And the very good point of that is having this technical stack predefined by the DIAS, you would be able to have the same technical stack for the operation. So it would have been so much easier to move from R&D to operation, because you wouldn't have to rework on the environment. You would have the same environment, just at another scale, and the people of operation could have concentrated on things very typical to operation, rather than being having to deal with oh my God, I don't have the good libraries, I don't have the good tools available. The one I can use for operation with some operation constraints are not the one that we're using R&D, which can consume a lot of time. And the scale up is eased by the DIAS concept. So if we had to do this with Sobloo, I would say that could help us save a lot of time. And just finally, as a wrapper, if you come to Sobloo, how could Sobloo help you in another context? Here we presented Starling, that's very dedicated to what Nestlé asked for, the oil palm commodity sourcing. But we could imagine that you would have some needs, and you would have to work maybe at R&D scale in a lab, and want to one day put it at the full scale to operate a worldwide service, for instance. To do this, for sure, with the DIAS concept, you would benefit, as I said, from the data and the services, the community, the tools. Everything is already present on the DIAS. And alongside with the cloud offer, this is what we offer on Sobloo. We have a strong offer with all the flavors of machines you would like, all the technology you would like. But one thing typical to Sobloo compared to the other, an extension of the DIAS concept on Sobloo, is that you will benefit also from the experience of our digital ecosystem at AIRBUS, because we have Sobloo, but we have also OneClass, which is our digital platform to deliver imagery and services about our commercial constellation for very high resolution, if it's a need for you. And you can benefit also from our colleagues from Up42, who are running a platform dedicated to developers and provide off-the-shelf computing blocks and images. So you don't have to worry about how to source the image, how to combine it to the computation, etc. You can design it very easily in a software as a service mode. And finally, one typical thing that we have is the experience. We have this know-how because of the experience of the 3 digital platforms, of the thematic services we have developed. For instance, Starling. We can help you defining, reassessing your architecture, or helping you to develop your use case, to grow it from the local or small scale or R&D scale less technological readiness level to a higher one. We can help you in that. Also with our knowledge of the thematic expertise, like agriculture or forestry here, environment, but also in maritime sustainable energies or for mapping, because this is our core business. So these are the reasons that could help you, make you like to use Sobloo just beyond the use of cloud and Copernicus data to be able to build something consistent in the end. If you need this, do not hesitate to contact us. You have my contact here. You have Diego's also email address. Feel free to ask any question about the presentation, about maybe your use case if you like, or about anything. We'll be happy to sync with you to help you. Thank you.
Yeah, definitely. I think I'd just like to add something that you mentioned for Starling, how important it is the feedback, because at the end of the day, like, we're putting these tools out there for you guys to use it, to make the most of it. But if we don't hear the problems you're having, and if we don't hear the difficulties, it's very hard to make it better. And as Adrian was mentioning, like, the only way to improve the Starling platform was to like provide a beta and say, okay, does this work? Does this not work? How can we make it better? With Sobloo is the same, and we have evolved quite a lot in the 2 or 3 years that we've been operational. So it is something really important, and I just want to quickly address before the break the discussion on the chat, which is great. It's fantastic that there's this exchange and all these questions asked. I think at the end of the day, this is hard when you look at it, when you look at the data and you look at the logs and you look at the numbers, but the level of abstraction on current software is so high that, and there's so much help, there's so much information out there, not only on YouTube, but everywhere on the web, that, well, as with anything in life, you know, when you just don't know very well, you just look for help. And I think in the end, it's a matter of time, given both the level of abstraction and the information out there, to like little by little start getting to know more about the subject. And I'm saying that with my first person experience, because when I came to this project, I had not been programming for quite a while. I mean, last I did was assembler and C and Java, and JavaScript wasn't really a thing. So, and little by little, you start building up your know-how and your skills, and especially you use these events, like I think Alessandra was saying, to like interact with people and get to know other people and complement each other and learn how to teamwork. And that's absolutely important. That's probably the most important thing you can do in a company like ours, especially, which is quite big. And I'll do just a quick introduction after the break of the company, because I just want to share things that are interesting for me, and hopefully it'll be interesting for you. At the end of the day here, this is like a learning experience for everyone. So yeah, I just wanted to address those couple of things that I thought that were really interesting, and thanks very much. We appreciate that you guys are engaged and just exchanging messages. That's really cool. Thank you.
Thank you, Diego. Thank you, Ludovic. Before training session on Sobloo begins, we will take a short break. During this time, Francisca Atena, Communication Department at Madrid Aerospace Cluster, is going to present what space means for you combined. Are you ready, Francisca? Francisca?
Yes, can you hear me now?
Yes. Are you ready?
Yes, I'm ready. Thank you, Nelia.
Okay.
And good afternoon, all. As Noelia said, my name is Francisca Atena, and I work in the communication department at Madrid Aerospace Cluster. Let me introduce you about the cluster. Madrid Aerospace Cluster is a private association that brings together the aerospace industry in the Madrid region, research centers and main universities, and the regional government, following the triple helix model of innovation. The cluster has more than 70 highly innovative and technological partners, from big companies to small and medium-sized businesses and startups that represent all the whole supply chain. The aerospace sector in the Madrid region is quite relevant. It represents more than 60% of the aeronautical industry and more than 90% of the space industry, what makes the cluster a relevant actor in this regard. Although the aerospace sector was able to mitigate the effects of previous crises in the last 20 years, on this occasion and due to the pandemic, the impact is being enormous, and it is very difficult to know the consequences it will have on this sector, and consequently it will have on the companies also. So for this reason, taking advantage of synergies and diversify become crucial, and the role of the cluster is more than ever vital, necessary. Madrid Aerospace Cluster is member of the main European networks, such as the European Aerospace Cluster Partnership, EACP, that encourage the sharing of experiences and that supports the implementation of projects regarding cluster innovation and development policies. Also, the European Network of Defense-Related Regions, ENDR, that brings together regional authorities and clusters to share experiences and best practices in building dual-use strategies and accessing European funding, particularly to SMEs. Also, EUREUS, that is the network of European regions using space technologies. But furthermore, Madrid Aerospace Cluster is a Copernicus relay. But what is a Copernicus relay? Copernicus relays is a kind of Copernicus ambassador in order to coordinate and promote activities around this European Earth Observation Program, its benefits and opportunities for local residents and businesses. The Copernicus relays are the voice, but also the eyes and the ears of the European Commission, both at local and regional level, to ensure that user needs are integrated into the program and to maximize its use at local and operational level. Madrid Aerospace Cluster also supports the participation of aerospace companies in national and European projects. And in this sense, the cluster participates in different projects. For example, NanoStar project, that is a collaborative platform to provide a relevant training on nanosatellite technology through student challenges. Asset Plus, that is a defense-related skills project that aims at reinforcing the human resource supply chain in the defense-related sector. Novesport, that is a sport accelerating hub for the SMEs of Southwest Europe. And a Galileo Information Center Chile, that was yesterday presented by our colleague Vanessa Ramos. The center is based in Santiago de Chile, and it offers support to the satellite navigation industry, application developers, and users, not only in Chile, but also in Argentina, Bolivia, Colombia, and Ecuador. And of course, we are partners of the consortium of Go to Space Hubs, in which we are in charge of the communication and dissemination work package. And that is the reason why we are presenting you today the campaign, What Space Means for You. Because the benefits of satellite navigation are all around us. And we would like to know if you believe the space affects your daily life. The global objectives of this campaign are to foster interest in entrepreneurship in and from space, to raise awareness about the possibilities for cross-sectorial technology transfer to and from the space sector, to raise awareness about the tools and resources like DIAS environments, and to provide information about the GoToSpace Hubs project itself and its activities and networks. So how can you participate in this campaign? You can participate in this campaign by answering a short questionnaire, just a simple one, just 4 questions, and sharing a photo or image on Instagram, Twitter, and Facebook with the hashtag what space means for you. That represents how space affects your daily life. You can see on the screen a QR code that you can scan and you go directly to this questionnaire, or you can find it also in the GoToSpace Hubs project. You can see the link on the screen also, but I'm going to share with you by the chat box also. We strongly encourage you to participate and help us to know how space affects your everyday life. Thank you for your attention. That's all from my side. If you need more information, please don't hesitate to contact us.
Thank you, Francisca. Thank you very much. Now let's move on the training session on Sobloo. I remind you this platform and Creodias too will be used during Hackathon tomorrow and Saturday. You already have access to both. Ludovic and Diego, are you ready for the training session?
I'm ready.
Yeah, okay, welcome again. All yours. Thank you.
Hi again, everyone. Okay, so let me see if I can share my screen. Voila. I guess you should be seeing it by now. Yeah, yes. I see it. Well, so that's all good. All right, so I'd like to start with a quote. Seen from space, Earth has no borders. And I think that's something that that all astronauts used to say when they came back from ISS. And something that's particularly true for an event like this one, where we got people together from so different places. And I think it's quite cool. I really like this idea, and I really like to see pictures like this one. So just a brief summary of what I'd like to discuss with you. As I said before, basically, I thought, okay, what can I share? I think it's interesting to share with you information in general about Sobloo, about how Sobloo works, about the company, maybe AIRBUS, how it works, because maybe you're thinking on a career or on aerospace in general. I think, I have a couple of hours, so I just wanted to share information that I think may be interesting for you. So don't hesitate to interact via the chat and letting me know when you need more information or something, or where something is not clear, etc. But what I thought we could do, to start with an introduction on both AIRBUS, because probably you're thinking, hey, this is not the A380, so how come you're working on the cloud now? And Sobloo, then on to the infrastructure, basically. Well, I'm the production manager, meaning I'm the responsible for making the system work, as well as for the help desk. So answering to questions of users, potential customers, use cases, etc. Saying, hey, what do you think we can do something with this? Could you be able to help us out? Sometimes we don't know. Sometimes we need to ask other experts. Sometimes we need to ask for help, ask other people. But in general, we're trying, alongside the European Commission and the European Space Agency, to foster the use of geo-intelligence data and the Copernicus program for the benefit of society, really. Yeah, so I'm more on the engine side, if you want to, more on the application or the tools layer. And yeah, I'll be presenting you a little bit how things work, so you can see behind the curtain what the platform relies on, which I'm sure you're probably more familiar than me in a lot of these aspects. And then we'll talk a bit about the application layer of Sobloo, meaning on top of like the engines, the foundations of the cloud infrastructure. How is it placed, and what kind of microservices are part of it, and how do we divide it, and how do we monitor them, and what do we do with them to make sure that it works. Then maybe I'd like to have a little break, because I think I read something like you can only keep focus for like 15 minutes or something. The attention span is going smaller and smaller with time. So, but you let me know, maybe we can just continue. And then I'd like to introduce especially the Sobloo desktop, of which I submitted you the access, the credentials for 2 machines that we deployed, for this hackathon. And maybe you've been already playing with it. It's basically a VM where you've got quite a few tools packed up from ESA and from AIRBUS to like do image processing, and then you've got all of the documentation on the API, etc., to try and figure out how to use this platform. And as I said before, I know this is not the most obvious field of work in the beginning, but with the amount of information and how easy it is with the APIs to end up obtaining information, you can do really incredible things. All right, so I'll just like to quickly start with the description of the company and where we are. So AIRBUS is divided into a commercial aircraft that, of course, you know about, helicopters, UAV or hubs, and then we've got defense and space. So in defense and space, we've got the satellite part where you develop satellites. If you're interested in this, there's in Madrid, in Getafe, they are primed for one of the next Copernicus satellites, for instance. Then you've got in Germany, then you've got here in Toulouse, in France, everywhere. Then you've got like defense, especially in the south of Spain, in Sevilla, and Cádiz, Puerto Real, as well as in Getafe, in Germany, in Manching, etc. And the important thing for defense and space really is how does it all fit together? How can you profit from the image and the geo information you've got from satellites, as well as plane, as well and hubs, to like put all that together in the cloud and make something out of it, instead of like having separate divisions, how to put all of that together. And that's partly what we're trying to do with the digital platforms and with the cloud. So you may say, what part of the cycle is AIRBUS on? Well, we're basically on everything. We're basically on developing and testing satellites, as you can see here, or the transportation with a Beluga XL. I don't know if you've seen one flying, but it's pretty amazing. It's really cool. You can put parts of a satellite in them or part of a plane in it and fly from one place to another. Sometimes they also come by boat, and then you have to block the roads, and then you see the trucks there going through national roads. It's quite spectacular. People sit there and eat popcorn to see it through. Also on the launch, and of course on the operations. You can do operations on the International Space Stations. This is what I used to work before. That's why I'm so passionate about space in general. And so-called the Columbus module of ISS. Then we've got operations on the satellite, low Earth and orbit operations, meaning when you put it on space and you start testing that it actually works. And then we've got the ground segment operations like Sentinel-1, Sentinel-3. Sentinel-1 is moving to the cloud next week. It's a pretty big event. I'm sure you can follow the news on ESA website and on some of the links that I'm going to show you soon. The move from the legacy VMware-based system to a cloud-based system with Orange, the same partner that we've got. And it's been a challenge, and it's quite interesting. So basically what the PDGS does is they receive the data from the different stations throughout the world. So you've got one in Maspalomas, you've got some always in the north, meaning in the Arctic Circle, like Svalbard, like Kiruna. I read there's a friend from Malmo here, so I'm sure you're very familiar with Svalbard and with Kiruna. And those stations tend to be on the on the Arctic Circle because you get more passages from satellites, so you get more information. And basically they process all these images and then they distribute them. And one of the places where they distribute them is on the Data Hub and the DIAS Hub and the Sci Hub from ESA for the Copernicus program that are free and accessible to everyone. And that's the reason why the European Space Agency and the European Commission have put quite a lot of money behind this project, this program, to make it happen and to say, well, I'm sure the scientific community and the research community will make something good out of it, and eventually we'll all be a little bit more capable on this digital transformation we're living on. Not this one. Just wanted to add this to my tabs. I have, to avoid the demo effect that Adrian suffered, I have kind of a lot of tabs already open. I just wanted to give a sense of different cloud operations that you can, as you know, use geo information, GIS for on airplanes, on GPS awareness on search and rescue services like we do with Galileo, etc. So these are a couple of the Skywise service or AirSense that also AIRBUS is part of. Give you a couple of links in case you want to check it out, in case that's something that you're also interested in as part of the learning process that we're all in when it comes to the cloud, which is because it is fairly new still. I'll come back to my slides. I'm sorry, I'm not really checking the chat, so maybe the moderators, you guys can stop me if you think there's something worth discussing, because I'm between two screens. Let me have a little look, see what you guys are talking about. If I can. There. 3 messages, questionnaires submitted. Okay, they were not for me, so that's fine. We can go on. So digital platform operations, that's the other thing we do on top of the things that I've mentioned, and that's why we're all here today after this quick introduction that hopefully you found interesting. And as Ludovic was saying, now we are integrating the 3 digital platforms onto Sobloo, meaning that you can get access to all of these resources. Depending on the project, depending on what you want, if you want to go further than the hackathon, if you have a startup or whatever. On the one hand, we've got one Atlas, that is the platform for AIRBUS very own high-resolution imagery from SPOT satellites, from Pleiad satellites. There will be a Pleiad Neo new generation launch soon that you can follow live if that's something you're interested in on the Ariane website. It's always quite spectacular, unless you can fly to French Guiana, which I'm not sure you'll be able to currently. Then we've got Sobloo that will go into a lot of detail, I think enough detail today. And then we got Up 42, which is more a tailor-based solution. The guys are proper experts on coding, and they can help you out with anything you want to do regarding geodata. And we serve them in a way. They use our APIs, they use our products, they use our catalogs, they use some of our apps to serve their customers who maybe say, hey guys, we need in Malawi or we need in Borneo information like this specific product to look at deforestation. I think some of them were looking at the rate the trees were growing in the last 5 years, and maybe that data is not necessary online, so we need to retrieve them to put it on service as quick as possible to make sure that we don't delete it, that it's available, and it's part of the process. As I'll tell you later, now we're moving on to customer-based approach, and that's why I was saying before that we really need feedback because we want to create things that are useful for everyone. And that's what we're doing with some new applications like a drive. Same as you have your Google Drive, you'll have your Earth observation imaging drive where you can store all the images you want, all the code. Maybe App 42 has made for you. Maybe you you got a couple of images from high resolution from one atlas to go on top of the Copernicus images, and then you're doing a study on COVID and how it's affecting pollution in China, or how it's affecting pollution in Europe since people are not traveling, or you're looking at the Amazon on Brazil, seeing what Bolsonaro is doing. You know, you can go into all kind of different details. And I just wanted to show that you can find a lot of information. You can find webinars on YouTube. You can find an intro on YouTube for Sobloo, and we have an App42 channel. So that leads me. I'm not going to play it. I just want you to be aware. You know, it's an hour long, so there's no point. But you know, you can, if you're interested in this and part of the hackathon, you can go in here and you can see there's quite a lot of detail on a lot of stuff. For App42, guys, you have a look at the channel. 5 things to know about NDVI, which we'll see later on the Jupyter Notebook examples. You know, it's a few minutes video, and it's quite interesting. And these guys are really reachable. So I'm sure if you wanted to at some point drop them an email and get in touch with them, you know, as Ludovic said for ourselves, like, we'll be really, really happy to reply and to help as much as we can. So just go and check all of these things out and all of the information that is available to try to step up on your knowledge on the information. This is the introduction on Sobloo, and I think it's not bad. Can you hear the sound on the video?
No, I can't hear it.
No. Okay, and I will just skip forward. I mean, you know where to find it, but basically this is the idea when we say like cross fertilization is how we create, how we make available certain tools, the SDK, the Copernicus data, the Copernicus core services, the App42 service for tailored solutions, the Orange platform with everything that Orange has to offer on people demographics, on people movement, on Orange is quite a capable cloud provider and company. So basically, Sobloo is not just a repository where you come and fetch your data. We want to be more. We want to be more, and we're working to be more, especially on demand with tailored solutions. And that was the most important thing that I wanted to show in the video. Other than some nice music, some very people really engage, and you know, and quite a nice moment. This is just to give you an idea of, so multi-spectral imaging, the degree of resolution that you can get on 30 centimeters with different layers, infrared or not. It's quite incredible, and you can imagine all the applications for maritime surveillance, for there we go, for agriculture, etc. Like the challenge you have for this hackathon, which is fairly interesting. So if we go slightly more in detail about Sobloo, you may say, yeah, Sobloo, so what? What's all of that about? As we said, we have data as a service, infrastructure as a service, platform as a service, and software tools to make a sense of all of this. So how do you use it? How can I learn how to use it? Data from Copernicus, Sentinel programs, some very resolution imagery from Pleiades and Spot Image, and the Copernicus core services that I'm sure you're aware of them by now, the third day of the hackathon, which are post-process images with information on maritime, on the climate change. We'll see them in a second. As infrastructure, we offer a secure cloud service and managed service in collaboration with Orange. I'll go to the Orange Web Console later. The platform we base our architecture on is Kubernetes. with some repositories that come from Monocular, like we've got Harbor, and we use etcd. We use some components made in house as well, and then the software capabilities that are the top layer to like dig into the data and infrastructure and make the most of it. The processing algorithms, some of them, as I said on the chat earlier on, are pre-coded, so you can at least have a go and just get a couple of results, which is always great when you don't have to do much. You may need to insert your API key that you can obtain from the website the moment you register, and then you can download your product and you can try and play with it and see what can you make out of it. Jupyter Notebook, that probably you're familiar with it. As a Java-based Eclipse-based solution, where you can, with using different languages like Python, you can code easily online. We've got the Sobloo desktop that is all-included machine. 2 of them have been deployed for this hackathon, and that's why I offered the Excel sheet, so you could like organize a little bit who's working with whom, depending on the teams, etc. And the toolbox and SDK. Just a quick review. You let me know if you know enough about this already, because I haven't followed all the hackathon. But Copernicus is the largest Earth observation data provider in the world, and that's thanks to Europe, to the European Union, which is great that we can put these projects forward. When it comes to Sentinel-1, we've got a lot of radar images with like products with different treatment. Sentinel-2, we've got all of these nice optical images. We've got on Sentinel-3, Sentinel-5P, because this is precursor. Sentinel-5 will be launched in a couple of years, if I'm not mistaken. And this one is more thought, is not proper imaging, but more atmospheric data, as you can see here. So the different type of process, a different type. Also for us, a bit of a challenge to see how do you present this on the website, because obviously on the interface, it's easier when you've got the map, at least you know the region, but either you can visualize it with WNTS or not. So different kind of fish, really. When it comes to the Copernicus core services, they can be divided into these different categories. We've got the atmospheric ones for air quality and atmospheric composition, ozone layer, ultraviolet radiation. The marine ones, observation, forecast by this service support of marine applications, marine safety, coastal and marine environment. Land ones, emergency ones, and climate change that can go from forecast, ocean elevation, heat map, etc. It's fairly interesting. We've got a partner company in the DIAS, the Sobloo consortium that operates the Copernicus core services, CLS, here in Toulouse as well. And the more complex products, if you want to, but at the end of the day, it's the more information you can obtain as well, and more profit, valuable information and research that you can make out of it. A few examples of these products, like the precipitation, the climate change ones, the index, the CAMS for weather forecast, lake coverage variation. And here you can just see the variety of products. When I mean that each one is a little bit different. We've got quite a variety on the center Germany, center Europe area. When it comes specifically to what products do we have online, coming back to the idea of serving the customers as the users, really, because it's a free platform, the best we can. We are focusing on the 3 to 9 last months for most of the collection, most of the products, and the previous one can be obtained either from the ESA repository, the data hub, directly going through Sobloo, obviously. So, but it's not an internal download from our repository. Other than that, you go to the data hub, and if it's out of the data hub in cold storage, then we bring it forward for you, but that requires 24 hours. And that is something that we have seen with our partners that was quite interesting for a lot of companies, as I said, that maybe said, okay, now we need information from 2017. I said, well, obviously that you cannot have everything online at all times, and it's just not very optimized design, really. So just let us what you need. Let us know what you need, and how can we help you. And so you can have a look on the data and service offers on the website. I was also mentioning before that we normally keep products with cloud coverage for Sentinel to optical images below 50%, because no one has told us till now that they have a use case for 50 to 100. When you basically on the image you're releasing clouds. But would that be the case? Obviously, we could retrieve them and make them available in a little time. When it comes to some of the services we offer, we've got the SDK that it's embedded. You could get it per se, just the SDK, but it's also embedded in the Sobloo desktop, and we'll play with it in a minute. Sobloo desktop also has other applications like ESA Snap, which I'm not extremely familiar with. Maybe you've used it before. If so, let me know, and let me know what you think of it. We have backend services that can be contracted with Orange, and we've got a few users that wanted to have their own tenant, and Orange fast track them with respect to the regular process, so the tenants can be open in very little time, about a week maximum. And then you can have some of your service manage and monitor immediately within the Orange framework. And as I was mentioning, after discussing with the users, that we've got over 1,000 users, we are putting together this drive to store all of the images on only one site, and you can process them directly on the cloud, as well as this easy API data warming interface to make the products available. Opa, looks like this one's not showing. Oh no, it's only because I've got animation, sorry. Let's go forward. Yeah, so we've got over 1 million downloads via API so far, just so you've got an idea of the size of the platform. Over 1,000 users. We've gone past this threshold already. 50 million search via API. A lot of them, because we see the statistics, we monitor them, and we know who's done what, really, just in case you're thinking of mischieving. We know. So some of them are just like a few products, just trying, just to see how it works and see if it's something they're interested in. Just it's part of the learning process. We don't really have many. We have 2 or 3 users that do like heavy downloading and heavy harvesting, but the rest of them are honestly part of the hackathon. We've served several hackathons. We are discussing with a lot of research institutions, and it's great. It's great because I think it's a learning process for everyone. As I said before, I have been working on satellite operations. I work on human spaceflight operations, and then I came to the cloud, and it was also a learning process for me. So I think this is quite exciting, and it's great to be able to have partners like One Atlas and App42 that can give you what we cannot give you, because I would not be able to prepare a tailored solution for you. I am able to let you know to make sure that the platform works. So as I think Alexandra was saying on the chat, like getting together and working as a team, and everyone with the different capabilities, what really makes, for instance, the Copernicus program possible in Europe, something that no single country in Europe would be able to launch and to maintain something like Copernicus or like Galileo. So that's quite a good thing. And in case you were wondering, we even have some downloads from North Korea. Yep. On the border with Japan, so we're also monitoring those. Well, that's what I mean by worldwide usage. About the hackathons, the last one we provided data for was this one, the Ocean Hackathon. I don't know if you guys, some of you took part of it. It was great because I attended the final just to see different projects, etc. And I was absolutely impressed that one of the projects that won, or the one that received like the first prize, the main prize, managed to see how 7 species had migrated throughout the Mediterranean Sea based on the heat map of this particular species, and how they had moved from one place to another, and how they were dangerous for the local environment on let's say on Greece, or on the coast of Spain, or in Italy, or in Malta. It was really impressive what they managed to come up with in university as well, after working together and using what was available for them. I was really impressed. So hats off to all of you for making something so great for all of these from our platform, and obviously no pressure. So this was the introduction, and I'd like to move on to the infrastructure. Just give you a bit of an idea on what are the foundations of Sobloo, what's under the carpet. We are based on Orange Flexible Engine, a secure public cloud based on OpenStack, high performance, multi-certified, worldwide hosting, bare metal, highly secured, blah, blah, blah. But yeah, it's good. On top of that, so we've got the orchestration layer from which, with another and higher level of abstraction, so we don't have to be on the command line all the time. We manage the Kubernetes platform. We do this using Rancher, that maybe you know about Rancher, and it's a graphic user interface that allows us to see what's happening and clearly interact and with the different workloads that are deployed on the Kubernetes nodes. And then we've got at least 3 different tenants, one for production, one for testing, and one for pre-production, the things that are in the pipe and are about to go into production. And then we've got a series of layers that make the systems hard and make the system live. So we've got a multi-satellite data store that gets the information on the platform. Then we've got external applications from servers like AIRBUS that we can install and upgrade on Kubernetes. But I just want to show you it. So yeah, we're going to the Orange Web console, and then we're going to Rancher and to Dynatrace. Let me just go to this one maybe first, because it's maybe a little bit clearer. You see it in a second, but you've got like the 3 Kubernetes masters that are like the 3 machines that really make this for how to administrate the load of the whole system for the platform. And if some machines die, then they need to come back up, and where do they go, and make all the management really. So that's really like the brain of the system. Then you've got what you call the Kubernetes workers, that are the nodes on which you deploy your system via Docker. If you know the Docker, it's not important. And then there's several load balancers as entry points that basically what they do is they manage the load. So they are smart enough to say, okay, this node, like this machine, can go on here, or can go on that one, depending on the resources, etc. So there's something quite cool as well that we have that is called Dynatrace, and it's a sort of layer on top of this that wraps it up, and it's like a big brother. So it's able to go on all the logs and uses artificial intelligence to provide with quick diagnostics and say, hey, there's an alert here, and you better check it out because I think it might be this problem. And it's quite useful. The moment you've got a platform this size, you cannot be checking every log. It's impossible. I mean, that's when I talk about the level of abstraction. You need to be really, really high up, because if you want to do assembler, you may as well do something else. So just quickly, let's go back to my tabs. See, we're all in the beginning, so we still have a few practical ones to go to. Don't you worry. So this could be our web console. Yeah, just to give you an idea. I think I'm probably logged out. So let me try. I hope I don't have like the demo effect and that everything keeps working. Is everyone okay? You're not too bored? Hopefully not. So these are all the different tenants that are part of that we manage, and you can just see that we've got, I mentioned CLS for the Copernicus core services. We've got the pre-ops. We've got production. I won't go into that one. For instance, we can go on to this one, and you'll see why in a second. It wants to load. Yeah, because it's the one I use to deploy the machines that hopefully you'll want to use. And I just wanted to give you an idea on how flexible and how easy it is really to like deploy stuff using this, something that otherwise would be extremely complicated. And here we see all the virtual machines, the Elastic Cloud Server machines that we are running on at the moment. There's the 2 machines for the 2 Sobloo desktops that we deployed for you. You have to choose a specific flavor. 4 virtual CPUs, 8 GB RAM is what is called an X-Large 2 machine, hosted on EU West, meaning Paris. You can choose the system this, and when I wanted to explain capacity, I just have to click here. It's the configuration is pretty straightforward, and that's pretty much for everything we have on Sobloo and infrastructure. Obviously, I'm telling you this because I'm the ops manager, so this is mostly my role. This is more what I do, more than being on the user end. That's where you come in, and hopefully you will let us know how can we be of more service. And basically, there's a little bit of monitoring also. We can see someone has been making it work, which is good. And basically, everything that you can do with fairly quickly. Object storage service, you can store it on your S3 buckets. We've got the size that we have over here, which is quite cool. And something will go later, but it's the Sobloo public dashboard. So you see there on the buckets the size of all the products we're hosting at the moment. But this is also publicly available. Just go to dashboard.sobloo.eu, or you can find it on the Sobloo website. Just here, dashboard. And you see how many peta we've got, which products we've got more. If we have any incidents, we'll let you know as soon as possible. We're fairly transparent. I mean, we had unscheduled issues, catalog incomplete due to platform incident. Boom, voila. And you can find a lot of information, a little bit of what's going on, the status of everything. So that's you can see everything's okay at the moment. This is continuously checking if it can go on and download and find products, etc., which is not too bad. I wanted to just show you a little bit how Rancher looks like. So here we have like different tenants we're managing. Here we can see the number of resources we use. As you can see, we have a lot of space. So we give ourselves some room in case something happens. Come here, we can see different nodes. This is what I was talking about, the Dynatrace, which is here. This is Dynatrace website. I'm not making advertisement. I'm just trying to let you know a little bit what it is. Just like a software intelligence platform, AIOps, hyperscale, application security, etc. All of this on top of, meaning going down to the bottom and reading all the logs and letting you know what's going on so you can react as quickly as possible as an operator. And in order to do that, we need to have some of the pods, some of the workloads deployed on Dynatrace on their own nodes, Docker. Over there, and you can see we have quite a lot of nodes. This one has a little bit still has some availability, so we have some more deployment. 62 giga, 16 CPUs. You know, we can see some of the node metrics, etc. So I won't go into detail. I don't think this is the goal of today, but just so you know, how does it work? What's behind it? I think it's interesting. Okay, I'll go back to the slides now, unless you say otherwise. So this is what we just saw. Okay, so we got the 3 masters of Kubernetes, and we have this 8, where basically we deploy everything Docker-based. Voila. Taking advantages of being on the flexible engine platform. Well, not necessarily to go into a lot of detail either, but basically saying that it's secure, it's redundant, it's fast, it's performing, it's has a lot of versatility. It's very easy to use. Well, is it a more economic console than WDS and Azure? It's quite similar to AWS. It's that's a personal preference, so I wouldn't go that far. But the performance has been tested to be quite good, the network as well. So you may say, what does have to do with me? Well, it means that the moment you have something a bit more complex, it will go faster. I will be a bit more reliable, because if you know, if one of the buckets has a problem, that transfer to another one, or the ingress will be easily replaced, and you may be able to continue and to be a bit more robust to the problems that every system has. A little bit more on the main architecture. So we basically harvest the products from the go to Sobloo dashboard. Well, we just did that. We harvest the products for Copernicus core service or for Sentinel, which means we obtain the metadata. We put them on the catalog, so you guys see that exist, and then we download the products and we put them in the S3 buckets, so you can retrieve them. If you were interested in a bit more knowledge on the different layers, we use all of these databases. We've got etcd, that has a key value database. Basically lets you know where you are if you were like harvesting products and you had to stop. Lets you know where to pick up from there. We use MongoDB to like store the products. We use Elasticsearch to have an index for all the research. We use SQL, PostgreSQL, we use Redis on all of these Elastic Volume services. We have like different source of login for monitoring. We, same as a computer needs buses, as a city needs buses for that matter, we have messaging tools that allow components to communicate one with each other. So it's called posting service, isn't it? So it's like you go to the post office and you post something and someone's waiting to receive it. And that's how it works. We've got 2. You may be asking why. Why would you have 2 when one post service already fails enough? RabbitMQ, it's something we use for WMTS, so for the visualization of products, and Kafka is something we use for the rest of the system. So we needed these two to collaborate with each other. And as I said, you can imagine it as a pipe, and people are just putting all data. At some point in the pipe is going to read it. They can organize themselves as consumers, so they all get the same data as if you were on an RSS or on a distribution list. And yeah. And then, well, we've got authentication, user control management, the APIs, and the data store. That basically, data store is what harvests and ingests the products. And this is just for the monitoring. I'm sorry, I cannot really go into the monitoring, but I just wanted to show more or less an average of the downloads we've got on Sobloo. This is via internal API. This is external API, which means products that either are not on our catalog, or that they are on our catalog, but we don't store them because they're old, or they've been deprecated by ISA. So then we directly redirect you to the DOS, so you can download them. And I was really interested in knowing, who's this bloke? Someone must have been doing like massive downloading, nearly 200 products. And I suspect that it's one of you. So well done. If you manage to download 200 products, that means that you are far more competent than me on your geo data. So well done. But it was interesting, and probably it's one of you guys. So if so, yeah, show yourself. Yeah, so on the data sources, just to add a little bit more clarification on how the DIAS, that's not only us, that all the DIAS, I don't know what Creo DIAS or Honda said, but basically we get access to interface from the European Space Agency that are called the hubs. There's one that is the sci-hub, sci-hub.copernicus.eu, that it's free, accessible by everyone. You just need to register. It's fairly limited in capacity, in power, in bandwidth. You can only download one product at the time, and that makes it not really useful for a lot of use cases. However, it's good enough for, depends on the case, obviously. But why am I showing you this? Or why am I showing you this one? This is called the collaborative data hub, that is very similar to the DIAS hub that we DIAS are allowed to use. And it's distributed on 3 different nodes. One of them, this is the same for the DIAS hub, has the complete online archive and long-term archive. This is what is called long-term archive. The other one has 2 weeks rolling archive, and the other one has 3 rolling archives. So through this is how we feed ourselves from this data. So yeah, so you have an idea. So we connect to something similar to this called DIAS hub, like this one. Okay, this is not accessible to you guys. You have the same interface for the Sci hub, and I can log in, and then you can have a little bit of like search depending on cloud coverage we're talking about before, sensing period, etc. You may find some products, etc. So this is our source for main Copernicus, for Sentinel products. For Copernicus core services, we've got CCS, we've got CLS, that it's that performs the operations and put them on our catalog. And other than that, we've got the One Atlas source for high resolution imagery. And then we've got, as I said, the App42 tailored services that maybe you'll find it interesting. Okay, so so you know, how does the DIAS actually work? It's not, we collect the information that the Sentinel PDGS payload data ground segments have transferred to the data hubs, to a DIAS hub, and then we exploit them in a way, making them available and adding added value tools to it. I hope that's clear and that's interesting. Yeah, surprised to see George show yourself. Now, well, Luis, we know. When I was just joking, I could find out who was it. I'm not playing policeman, but I believe it must be one of you guys, and it's great. If you're already that capable, I'm sure you'll get like great results on the. Good to know it's you then, Luis. you managed to make something great out of this challenge. So, all right, we go to the application layer. Let's check it out, what Sobloo is all about. I wanted to show you the dashboard a little bit. I wanted to, for you guys, in case you haven't done it yet, to register and generate your own API key that will be used for the tool of the API. Not for any other API, the rest do not need authorization. And we have all of these. All the tutorials can be accessed either going to Sobloo to Sobloo documentation, or either directly going to this link. And we're going to download a couple of products. Okay, so we just have a look at the interface. Yeah, of course, we are RGPD compliant. Thanks, Ludo. So yeah. So well, this is our main platform that I'm sure you're familiar with the interface already on Sobloo, sobloo.eu. Voila, we've got quite a nice interface in the beginning. The global data offers, satellites, the core services, mobile data, thematic products. Well, we have here the global data offer based on different sentinels that I showed you before. We had the Muscat products, well linked to the Muscat catalog, as was asked very, very early today. The Spot and the Pleiades. Copernicus core services, a bit more information on what each one provides. SOCAP, mobile data. This is fairly new. This is something we just added. It's called FluVision, and it's something from that Orange has developed for data delivery. So, well, I think you cannot see the video. You cannot hear the sound anyway. But basically, something that helps correlate certain indicators with the movement of of devices of people. RGPD. But it's something, like we just try to add as many added value services, so in the end the user can put them all together and make something incredibly useful out of it, like what I was telling you about the invasive species on the ocean hackathon. That really blew my mind. Voila. I won't go much into that detail. Different what we said, managed operating system, the Elastic Cloud servers with a different type of flavors. Computing, cloud services. Here on the marketplace, you find a bit more information on the very high resolution. Voila, the back services, Snap, etc. Which I think could be quite interesting for you. We've got some news, help, get started, documentation, the GitLab, and the fact. The moment you are logged in and connected, you can send us a ticket if you want to through support. Voila. So you can get in touch with us through that, and we appreciate it because it's easier for us to track it, and it doesn't really depend on. It's slightly easier. So we would appreciate it. Of course, you can contact us by email as well. But if you're using the platform, it's good to make use of the ticketing system as well. The dashboard that we just saw before, news and events, etc. And here we've got on a public GitLab, gitlab.com public. We've got the different tutorials and documentation on how to use Sobloo. And even you've got an authentication tutorial. So that will be the one that you should follow if you haven't done that yet. I mean, it's pretty straightforward, but we have quite a lot of procedures for everything. Basically, you just register, complete your profile, look at your settings, and then what's key is that you go to API keys. On the left, the moment you go to your profile, you click on my profile and you go to API keys and you can generate a new key. And you need to copy it the moment you create it. So if you want to download via API, which again, depends on the use you want to make of the platform. If you're targeting a very, very specific product, you can do it through the website. You can download a couple of products and maybe that's enough to do the research that you want to do. I don't know, maybe you're into massive download and you need 100 products and throughout 5 years, and then, well, we're talking about something different. I don't think you want to download 500 products by hand. Yep, okay. So no more further ado there. I deleted the cookies so I could go through. It's not the first time that I'm on the platform, but the moment you first connect, you get this tutorial, which, if I'm not mistaken, it's also data catalog and documentation. I think it might be here. Yeah, so it's also here, step by step. But we can go through it together if you want to. So the moment in order to get here, you just click to global access to all data. Okay, and you just get here. And if you want to go through this again, as I said, you just delete your cookies. And then the moment you connect, you'll see the tutorial again, which is what I did. You can search what you want, combine words. For instance, you can search data in Spain and France. You can write Spain's France if you want to. Yeah. You can draw a box if you want to filter data from like a certain region. This board allows you to see the analytics and filter data on several criteria. Okay, what criteria is that, please? WMTS, so meaning you want to visualize the data. Local storage, because you want to download the data from our own S3 buckets and not from not be redirected to the ISA. Hubs. If you're looking for offline data, that's interesting. That means that you already know that you want things from more than 9 months old on our platform. So meaning we've got the metadata, we can tell you what the product is, but you cannot download it from us. Then you could just go here, and then you could go on the different collections, even the different type of product, the level of production, level 1 or level 2. I mean, all the details on these products, I'm not going to give them to you because I don't know them by heart, but you find them on the ISA website or on the Sentinel per se website, on the Copernicus program. I don't know by heart the difference among them, and I don't know which one's more useful for you. We also have the cloud coverage, the timeline filter on the bottom, time shortcuts if you want to, access to the list of products by clicking here, plop, comes out. You can visualize this in different ways. You can do some sort of the geo search, the distance between the center of the map. Hi, Ankur. You're raising your hand. Yeah, would you like to say something on the chat? Okay. Well, keep going. If you want to view the WNTS products, just click on here. You have to select one of them. You can have different information layers, roads or country or names. Top of Voyager, bright basic cloud matter, positron streets. You can draw a polygon if you want to. Change them, display of the data on the map on the 100 features. Yeah. You can also change the base of the application in case you want it to be this upright or other. Yeah. So if we had Sentinel too, because they're like easier to visualize, and we want to say WNTS, and we want to say we have more local storage, for instance. We say, hey, where's the Carlos III? I don't know, still on the north. Well, let's have a look over there, see what we can find. Reduce the cloud coverage so we can see something a bit clearer. We have 305,000 products. Just need to give it a second. My home bandwidth may not be the best. You can also choose a timeline. If I minimize the search, look for something recent. Let's see if we can select one of them. My bandwidth is freezing a little bit. Sorry, guys. No, these are too old. From okay. No, 2021. No, it won't allow me. Yeah, well, at least it's found 4,000 products is 350,000 the moment we narrowed the search. But I think I've got an issue here with my bandwidth, so I'm just going to proceed. Well, you can imagine that I have a few products that we'll see anyway, so don't worry about this one. But basically, you can either filter with this one or with this one, and then you'll be able to select an area of your interest. Yeah, like you go here, then you have a bit more of details on the products. Sentinel 2, you have the size of the products, you have the name that then you have to like translate if you want to download it, and you can try and visualize the product. Here we go, that's working now. The WMTS layer allows you to remember that you have to filter that it's a WMTS product, and like that you are able to like see on the mountains of Aragon, close to Jaca, the northeast of Spain. Yeah. Yeah. Mm. Oh well. Where are the products? So the products are here. Depends on the filter. So we've got like 4,000 or so. Then depends on all the time that we are. Yeah. And the time that we are selecting. Depends on the search that you want to do. Let's see if we want to do thing. We have to extend the vision. You see. Anyway, it's 6:20, so I better move on. Okay, so if you want to download a product, in principle, the only thing, you can here, you can just download it by clicking on here, and download should start automatically. So this is a fairly easy way to access the catalog, the different products. I chose Sentinel 2 and I chose Spain, but if we reset the filters, yeah, the problem of visualization, as you can see, it's my internet, or the bandwidth really is not. I have quite a few things open to show you later, so it's not necessarily that the platform is not. Well, using how to make it till there, how to get to like the download, and basically then you just click on the little blue cloud. The moment you come here on the information, and you should be able to download the product, as you can see here. So the product's been downloaded. I'm going to stop it because I don't need another giga. Okay. Well, basically, we've managed to filter with different. Now it's coming up. Maybe there was a glitch there in the network, and now it's coming up. And yeah, you can find the ones that you're after, depending on what you want to do with them, and you can download them by hand like that. Okay. And again, if you wanted to get the API keys as showed in the on the wiki, you go to authentication tutorial. Just on the profile, you go to the left and you get your API key. Okay, on my profile. Okay. Good. So come to this, I'd like to call it a 5-minute break. What do you think? Is that okay with you guys? Is that okay with everyone?
Yes, let's take a break. 5 minutes, okay?
Okay,
Okay.
let's put this on.
If someone
right.
wants to ask Diego something, you can write your questions in the chat box or speak into your microphone by pressing before the raised hand icon, the icon with the hand up. Okay.
I'm just going to grab a quick drink though. Okay, so I'll be back in a couple of minutes, and we can still go. I'll see the questions. Okay, just one sec.
Thank you, Diego.
All right, so 5 minutes gone past. Let me have a look at the chat. Which machine? I will be using a Sobloo desktop, a different one from the two that are deployed for you. So if you mean that you want to go onto a Sobloo desktop, you can use either. Fail request, check your API key. I mean, depends on the, well, I guess you put it on the header as API key space, the API key for the authorization, right? You use the Jupyter Notebook pre-coded examples. That's bizarre. Maybe check, because it happened to me that I didn't copy it properly. I only copied like 2/3 of it.
This is Lava. I try to give you the presenter to open your
Okay.
microphone.
Can you hear me now?
Go ahead. Yes.
So I don't know which machine, because I just logged into one, but the key is correct as far I can see,
Okay.
because I put print, so it printed the key.
Well, I don't know exactly what could it be. I'm going to go through some of the Jupyter Notebook examples through two of them, and then maybe we can have a side discussion later on, and to see exactly what your problem is, and maybe you can share your screen, or we can be in touch later.
Okay.
But at least let me continue. Let me show it on my screen, and then we can see what's going on. Thank you. Okay. So just like now, to go on to the Sobloo desktop. So we've got this. We're getting to the end of our tabs. This is mine. So as we said, there were like this spreadsheet. Can you still see my? Can you see the spreadsheet now?
Yes.
Yes.
Sorry, no, I changed tabs on the other screen. Yeah, so basically, well, the only mean that I wanted to give to this is, like, as you can see, that you can have a few people connected, so at least you could organize yourselves onto the machines. But yeah, there's these two, the Sobloo Desktop 1 and the Sobloo Desktop 2, with this the username and password, so you can just connect, and I presume that you are in one of them. I had set up a few things to make sure that they were ready. So I wanted to go through here's the Sobloo desktop, first of all, as you can see, which is nothing more than an embedded SDK system onto a virtual machine with a few tools that we believe are useful, and the Copernicus program thinks they're useful to the data processing. So we've got Snap, QGIS, Jupyter Notebook, and a few more of them. So yeah, so we're back at the tutorials and the documentation. I presume this is Lava. That this is where you start and then went to Jupyter Notebook. As you can see, the only API that requires authentication, meaning that requires the API, is the download one. Then if you use the rest, the quick look, the WMTS, etc., you just need the product information, really. There are a few examples on Jupyter Notebook that can be found here. This is the Python code that you can directly execute. So what we were going to do, it's we'll do like search and download of some products, both in through the Jupyter Notebook and just directly through the API. Okay, so there are many ways on which you can find products that we have seen. There's, for instance, the possibility of just finding it directly on the web interface. Then what you may want to do, unless you want to download the product directly, you may need to translate the ID, the name of the product, onto the UID that as the API documentation requests. Hold on, not just yet. So this, for simplicity or also to show something else, you can use it with a RESTlet client, and it's fairly easy. It's in case you want to use this one, this is just a Chrome extension called RESTlet, and you only need to type in get method, then you use the API, and by the end of it you write the product. You click on send, and you obtain the ID. And this is the ID of the product that you want to use in order to go with the APIs. I may copy all of this onto the machines, onto the chat directly, if you want to. This is something. If we go back to the desktop, this terminal is just the Sobloo desktop been initialized. Oh, there we go. So this is something that you can also directly do via simple curl. Use a curl and you get the information that you want. And you may want to say, well, actually, you added a few more parameters there. So, well, yeah, I did a cloud cover percentage, and I also added a polygon to identify the region where I wanted to find products. If I just do it like that, like this first main curl, you get a series of different products with their IDs, 1, 2, several of them. And then you can use other tools, obviously, like JQ, to just like choose one of the IDs. And then this ID, you can use it with the Quick Look API. Type it on the navigator, Sobloo API, Quick Services, Quick Look, blah, blah, blah. And it shows you the quick look of the product to see if that's the one you were interested in or not. In case you're wondering how to draw a polygon, that you probably know it, there are plenty of applications that allow you to do it. Voila. And there's the information you need to pass as a parameter to the request. For instance, if you then wanted to download one of these products, and that's probably what we were mentioning before, you just need to write the header, authorization, API key, then your API key, and then just the product. You can see you can just do that directly by curl. You can do it. There's a Python code on the Jupyter Notebook to do it, and we'll see it in a second. It's one of the examples with the SDK. But there are things that are, I mean, at the end of the day, you choose how you work with the API. And either you use clients like the one I show. You can see the number of requests that I have already saved here, because I want to test that the DIAS or the Sci-Hub or the UMETSAT, which we didn't mention, but UMETSAT also provides some of the Sentinel 3 products, that they work or not. We want to go to one atlas. We want to change the certificates more on the infrastructure side, etc. So, you know, it's up to you at the end of the day, whatever is more comfortable, depending on what you want to use. But at least just wanted to show that you can just go to your terminal, bam, curl, copy paste and you can download one of the products. You can use an extension from Google Chrome, or you can also go to the Jupyter notebook. If we come here in the beginning, we've got that's the main page of the Jupyter notebook, and we can maybe go to, we've got the desktop, we've got the tutorials for EODAG, that's the embedded SDK. The first one that, I don't know if it's here, that's the result. Yeah, it was this one, wasn't it? Yeah. So basically, on the documentation on the wiki, you find this is code that is already written to help you find out the list of products in the area of Spain. You have all of the dependencies, all the functions that come on the top from it. So you need to make sure that you have all of them on your code before you execute it. That they may depend on some of the previous functions that are also listed here. But the only thing I've done with this is I'll place it here. I came onto a Jupyter notebook and I went on desktop. Yeah, I went on desktop, new text file, and I just copied everything and just made sure it was right. And obviously I had to debug it a couple of times because I was a bit silly on the way I copy pasted. I had to add these two functions as well. I had to import them. But now at the end of the day, when you just connect onto Python and you just run it, so you can do new Python 3 like this one, and you only need to like import example. That's how I named it, example.py. You get 27. Is that it? 297,000 products with the different IDs on the region, on the area of Spain, overlapping with Spain. You may say, well, why is there an exception on the rendering? It's not in all of them, but it is because, as we've seen, all the products are not images. Some products are Copernicus core service, like this one, like a maritime product that interface with the region of Spain. And that could be a quick look. This could be a different one of Copernicus core services, so that's why maybe you get some of those warnings. But at the end of the day, the only thing I've added from this this ready-made code, it's well, nothing in this case because I don't need just the API key here in the beginning, like that. On the header, same as we saw on the terminal on this one. Yep, so authorization, API key. And then the product and where you want to save it. Okay, so this was one of the examples that I wanted to go through. We wanted to see also, yeah, well, we saw the example here of the image with a quick look already for the download. Then for the EODAG, that is the embedded SDK, we got 5 different pre-coded examples, basic burn areas. One of them is to calculate this one, calculate the vegetation index that we saw Up42 have a nice 5-minute video where they explain a little bit more about it, more than I know about it. But the only thing that you have to do here is to modify your API key, like I've entered mine here, and then you just need to, well, you can modify if you want to the area where we're looking. In this case, we want to see the center of Toulouse, as you can imagine, and also the dates. This could be the same result we could obtain. If we click here, it's exactly the same result. Obviously, it's not very readable, but we get the different products that are going to be part of the vegetation index calculation. And then the different subsequential functions allow the plot to show the areas with vegetation or not. This is the river. This is the Canal du Midi. And these are the parts with different vegetation. The way it works is it quantifies the vegetation by measuring the difference between the infrared and the red light, which is absorbed. So that's why also the coloring. And in order to execute this one, the only thing I did was to type in that, and then you can go to cell run all, or delegate to run if you're on the beginning. Just needs to process it for a little while before you obtain the result. Okay. This one is the search and download example. And similarly, the things that you can modify are your API key, as well as data, and as well as the region. In this case, we're looking for Sentinel 2 L1C products in the south of France. Firstly, the maps the products are searched for. We obtain a certain number of products. See, and then we choose to call from the list of products the first one. It's something you could modify anything here. I mean, you could want to like for the second one or the third one. You can. That's what it's made for. And then you could just go and download it. And similarly to the previous one, you just go to cell run all. Searching products on provider Sobloo, sending the request, sending different search requests. Found 619 products. So it creates a list with the results on a JSON, GeoJSON. It's a tricky one. There we go, and it's downloading. It's not bad speed in the end. It's better when it's an internal product. Okay. There's a different one. We could also maybe give it a go. I haven't tried this one. Search for burnt areas. Might need a little bit of debugging. We'll see. Copy. Please change me. You're so kind. Did I do it right? Hope so. Let's see. On the end of May, a wildfire began in the north of New Mexico. The fire has burned 36,000 acres. Well, that's something good and worth surveilling, isn't it? We'll need to install send to core instructions in here. Okay. Well, I'm just going to run it and hope for the best. Workspace visualization. So the different segments are being executed one after the other. Service unavailable. I think the product, maybe the data was not. Yeah. Obviously, we don't have products stored from them, as you can see. So it's something we have to modify. Like with different dates. But when you see something like this, just double check, because the Jupyter notebook has not been upgraded for a while. Well, not for a while, but I mean the examples, the demo, the tutorials. You know, we don't change the dates manually all the time, and actually I think it's a good exercise to debug a little bit. But these products are offline, so they cannot be found on Sobloo. We need to go and retrieve them from ISA. I see some people are leaving, so let me just, we have to modify this and run it again, but I really wanted to show you the QGIS that I had it open here, because connection error. Well, phew. Okay, well, we'll better get on with this then. Yeah, okay. So this is the main image, the main interface that you get with QGIS. I had downloaded a product here. The one I had downloaded with the curve, if you remember, that I named it like that. And just extracted it there. It's quite a big one, it's like 800 mega. And then from QGIS, what you want to do, if you want to visualize a product, you want to go to the WMTS. That is where we are at the moment, and you click on the WMTS, okay? And then you want to create a layer like this one, test layer. If I go and edit it, so you just need to add, it's simple, this one doesn't need the API key, doesn't need authentication. So you can name it however you want, and then as we have seen, as you can see in the, in the documentation for the API, same as the quick look, etc. services, we use the quick look and the ID of the product to see to obtain the first image of the product. We use the WMTS to generate this additional layer that we allow that allows for further visualization of the product. So that's the only thing you need to do. You need to add the ID, and you just add it. Once it's done, just click on add it to the map. And here, Untitled Pro, because I just did it, is where you get your image with a slightly more or less definition, and you can zoom in, and you can have a slightly better visualization of what's going on here on the port. And maybe this is something that could be used to determine the number of vessels that are coming in terms of maritime surveillance, or depends on the region that we're trying to achieve. Also in terms of agriculture, of the areas that have a different vegetation index, as we have seen, density of the population, etc. So that concludes for me what I wanted to show you. I wanted to show the Jupyter Notebook and the tutorials, as well as the search and download. If we hold on, if we go back to the presentation, here, this presentation on the desktop play, there's on the documentation for the APIs. We did the EODAG with the Sobloo SDK. We use the RESTlet client as an easier, faster interface, or curl or Python for the search, quick look, and download APIs. Within those three, we use these two different tools. And in principle, because I see some people are leaving, this concludes what I wanted to do for the demo with the tools that we've got. You've got here our contacts, and as well I encourage you to use Sobloo Platform and the help desk ticketing system to submit queries that you may have regarding utilization, etc. And yeah, thank you, and Godspeed with the challenge. I'm glad we didn't have major connection issues either. But we've got a bit of time now, so I'll go back to the moderators. I don't know if you want to do a Q&A, a wrap-up, or if you want to look into more detailed issues. Oh, thanks, Eugenio. I'm glad you found it interesting. Cheers.
Thank you, Diego, for this very interesting practical session. I remind you all, this platform and Geodias will be used during Hackathon tomorrow and Saturday with technical support. I also remind you already have access to both. At the Hackathon, you can share ideas from your own experience and work as a team. I remind you with tomorrow and Saturday. Okay, that's all for today. We are waiting for you all tomorrow. Tomorrow, we will have the opportunity to attend a roundtable with the participation of Safir, Tatexia, and Mundi Web Services, and the presentation of Challenge. Thanks to all, and see you tomorrow.
Well, I just copied on the chat some of the commands that I have been using. Careful with that thumbs up. Sorry about that. I just copied it automatically. But about the documentation, so maybe you want to directly copy paste some of the commands that I have been using with the API and with some of the user IDs. Well, here you have to insert your own API key. Just please feel free to do so. And if you want to, well, yeah, just reach out. I really hope this was interesting. Thanks for the feedback. And that's what we do really. What we do with Sobloo, with this platform, is we want to foster the utilization of digital platforms, and we do our best to be useful. So thanks very much for the opportunity of being here and presenting this.
Thank you, Diego.
Thank you very much for accepting our invitation. And if any participant, if any attendants have any questions or doubt, is the time. Or probably also on Saturday, you can resolve your doubts.
Yeah, and the Sislava, if you're still having issues with your API, just send us a screenshot or send an email or create a ticket if you want to, and just let us know, okay? Because you were saying you were having issues with your API. Okay.
Thank you very much. Thank you, Sobloo team. Thank you.
Thank you.
Gracias a todos. Bye.
Bye.
Gracias, Diego.
Muchas gracias. Bye. Thank you.
Thank you very much. Thank you. Hola.
Hola, muy buenas.
¿Qué tal?
Bien, bueno, hoy era sesión